when we graph something, we graph a certain way. Like this point here, I would go over x3, and let's go up 1 though. I don't want to, let's go up to here. And then y is going to be 4 up. So we would call this point x comma y, or over 3 up 4. That's rectangular graphs. And aren't you under the impression that that's the only kind of graph there is? But actually there's an infinite number of other graph formats that you can do. Probably the most used alternate form of graph is what we call a polar graph. And a polar graph, a rectangular graph, is what you're used to. And you plot everything x comma y. For a polar graph, you go out r angle theta, which sounds weird, doesn't it? But all that we're doing is, let's say we have a point right here, and we're going to go out, here's 0, we're going to go out 1, 2, 3, and 4. So r would be 4. From the center, we're going out 1, 2, 3, 4. And then for the angle theta, we start at 0, our old unit circle 0 reference angle, and then we go up to whatever this is. This is about pi over 3. And there's our point, 4 pi over 3. Where do you think in this world you would use something like this? Who would use something like this? Can you think of anybody? Yeah, like not only a ship, but probably subs when they're underwater. Subs would have this, and they would have depth as well, so there'd be 3 dimensions. The ships would probably mainly be 1 because they're on the surface. Isn't that interesting? But anyway, that's all there is to polar. Instead of going x, y, we go out r up theta. So if I'm going to graph a point 4, 5 pi over 6, here is the point, 4, 5 pi over 6. Me personally, I like to do the angle first. Go 5 pi over 6. So here's 0, and I go, or 0 radians, and then we go 5 pi over 6, which goes out like this. Then, to get 4, you go from the center, 0, 1, 2, 3, 4. And there it is, 4, 5 pi over 6. See, easy? Now we could also graph the negative angles. Like let's say we went negative, let's say we did 3 negative pi over 4. No problem. We go, negative pi over 4 is going to be like this. And we go out 1, 2, 3. So there's 3 negative pi over 4. But there's more yet. What if r was negative? Well, that doesn't even make sense. How can the r be negative? But let's say we had a point that was, I thought I had one here. Yeah, here it is, here. Let's say I have a point negative 3.5 pi over 4. So we're going to do it. We're going to go pi over 4. Here's pi over 4. And we're going to just go out, forget about the negative. 1, 2, 3. 1, 2, 3. 4.5 is going to be right here, or 3.5. There is where 3.5 comma pi over 4 is. Any guess on where negative 3.5 pi over 4 is? Any guess? Here's 3.5 pi over 4. No guesses? Go straight through the origin, like tangent did, and then go out 1, 2, 3.5. This is negative 3.5 comma pi over 4. So you just go out to pi over 4, and then you go opposite. Could you do a negative 3.5 negative pi over 4? Yeah, you could do that too. And we're going to do that. And that's it. That's the section today. I'm going to move to, if you would, go to assignment day 1. We're going to do a couple of these together, and then I'm going to give you 4 to do for tomorrow. You're just simply put going to find all 4 ways to draw up one polar point. So I'm going to start here, 2 pi over 3, and we're going to do 3 other versions of that, which are the exact same. So here's my circle. And here is 2. There's 1. There's 2. We're going to go pi over 3. Here is 2 comma pi over 3. There's one way to write it. Now the other ways to write it are going to be another positive 2 and 2 negatives. So you can start by doing that. That's the easy part. There'll be 2 2's, 2 negative 2's. These will all make the same point. Let's do the easy one here. Let's do the negative theta. So to get the 2 and then we'll do a negative theta, what happens is this is pi over 3. How do you get that? It's not hard. Yeah, you go to pi over 3 and subtract 2 pi, which is 6 pi over 3. That's the same as 2 pi. So what's pi over 3 minus 6 pi over 3? Negative 5 pi over 3, yep. So there's one same point, 2 pi over 3, but you're going 2 and then you're going negative 5 pi over 3. Gives you the same point. Now there's another one we can do, the negative. So what you're going to do is you're going to find this spot down here. So this is going to be 2, and then I'm going to take this one, and I'm going to take pi over 3, and I'm going to add pi, 3 pi over 3. I'm going to add pi. So what's pi over 3 plus 3 pi over 3? 4 pi over 3, yep. So if I go 4 pi over 3, I'm here, but when I make it negative, it goes back to there. And then for the negative, just take the 4 pi over 3 and then subtract 2 pi. So 4 pi over 3 minus 6 pi over 3 is negative 2 pi over 3. Isn't that interesting? That's something. You can find 4 ways to describe this point right here. If you want a shortcut, this is r negative theta. This is negative r theta. This is negative r negative theta. What you did here is you took theta, subtract 2 pi. This one, you took theta and you added pi. And then you took, I guess you could say it, theta plus pi, and you subtracted 2 pi, didn't you? So that's just like theta minus pi if you wanted to do it that way. That would work as well. I know, that's kind of confusing, isn't it? But you're going to get better at it. Let's see what you can do with this number 5. You have, or number 2, 5, 7 pi over 4, 5, negative 5, and negative 5. See if you can get these other 3 angles. Okay, so there's where 5, 7 pi over 4 is. 7 pi over 4 is this. So if I want to go the other way, it's going to be 5, go 7 pi over 4. I'm going to use the same colors though. 7 pi over 4 minus 2 pi. 8 pi over 4. is that negative pi over 4? There you go. So that worked great. Okay. Now for this next one, what you're going to do is you're going to find this spot here. Okay, and that is just going to be 7 pi over 4 plus, actually I'm going to subtract, because we're going to keep between 0 and 2 pi, I'm going to subtract 4 pi over 4 to give me 3 pi over 4. It wouldn't be wrong. It wouldn't be wrong if you had 11 pi over 4, but we like to keep it between 0 and 2 pi. So then to get the last one, you take 3 pi over 4 and then subtract 2 pi, 8 pi over 4. And that will be negative 5 pi over 4. Those 4 will give you the same point, giving you some flexibility to understand polar points. You're going to, for tomorrow, do 10 and 12, find the 4 for those, and 13 and 16, find the 4 for those. Let's wait with 37 through 45. Let's wait with those, please. And then the last thing for today, we're going to play Battleship, and we're just going to get a chance to drop the board. You have 2 boards. This is going to be your board where you're placing your ships, and these will be the locating the other person's ships where you'll take your shots. So we're going to start with, you're going to have 1 or 2 of the, you're going to have 1, 2 ship, that's the 2 spots. So somewhere you're going to put a star next to a star, and it could be on the same angle or on the same radius. Either one is fine. Can't snake around like that. It's just got to be in a row. And then you're going to have 2 4s somewhere. So you're going to have there's a 4 here and a 4 here. Then you're going to have 1 5er. That would be this one here. But you could go 1, 2, 3, 4, 5 would be fine. And then the biggest one is a 6. And I guess this is the 6 and this is the 5. Well, the restriction is you can't be next to. So if you look at this one, you can't put anything within 1 of this ship or within 1 of this ship. Okay? They can't be right up next to each other. But you can go in here if you want. You can go through the origin if you want. All those are fine. So you're going to put 1 2er, 2 4s, a 5, and a 6 somewhere on your board, and then you're going to take turns apart from each other to guess where those are. I would mark the hits on this one, and then see how they're doing with yours. So get into groups of 2, and then you're going to put your ships on right now.